The lecture module this week is going to focus eventually on weather and weather-related processes. But before we get there, we have to move away from the movement of the atmosphere and its circulation towards the formation of precipitation. And we have to start that off by talking a little bit about water in the atmosphere. Water, of course, exists as a solid, liquid, and a gas. And in the atmosphere, it exists in all three of those forms. Solid, of course, is snow and ice. Liquid is rain. The gaseous form is water vapor that's all around us in the atmosphere. Very tiny particles of water suspended in the atmosphere. Water, of course, goes through a number of transformations, some of which are very obviously like melting and freezing. It also evaporates and condenses as it goes between its gaseous and its liquid phase. And it also moves into a solid phase, either through the process of sublimation, where it goes from its gaseous form into its solid form, or it goes the other way, from its solid form into its gaseous form through the process of sublimation. A really important thing to remember about water in the atmosphere is that as water goes through these various transformations, heat is either released or it's lost in the atmosphere based on what sort of transformation is taking place. If, for example, water is going from its solid form, ice and snow, into water vapor, or it's melting, that's going to ultimately use energy up. It's going to require energy. If it goes the other way, and one of the most common examples of this is when water goes from its vapor form, its gaseous form, to its liquid form, energy is actually released into the atmosphere as the molecules require less energy to stay in that form. So that latent heat of water in the atmosphere is an important thing, and we will come back to it. Water and its ability to be in the atmosphere is directly related to the temperature of the air. And the simplest way to say this is the warmer the air is, the more moisture it can hold. So a very warm parcel of air can hold a lot more moisture than the same size parcel that's much colder. And that's because of the agitation of the molecules that are in the atmosphere itself. This is really important because what it means is that if we find a way to cool air off over the course of a few minutes or hours or days, that air is going to lose its ability to hold onto moisture, as this diagram shows right here. As the air loses its ability to hold onto moisture, it may eventually reach a temperature point, which is called the dew point. And the dew point is the point at which the air can no longer hold on to its moisture because it's much cooler than when it started. Its relative humidity has gotten higher and higher and higher. And when it does that, hits the dew point, it starts to spill out of the air, either as dew or it condenses to form clouds or precipitation, whatever happens. This principle is super important, and it's worth taking some time to wrap your head around it. Think about how water behaves in your life. When you step out of a shower and you're wet, it evaporates. It's cooler. And it's much cooler generally in the winter when the air in our house is very cold because evaporation is much more efficient and relative humidity is lower. Why is it more efficient in the winter, and why is the relative humidity in your house lower in the winter? It's because you bring air from outside of your house into it to heat it up, and that air is very cold. It doesn't have very much vapor in it. So once you heat it up to room temperature, it suddenly is much larger, like the larger circle here, and can hold more moisture, so the relative humidity falls. There are all sorts of interesting relationships that happen in our daily life that revolve around this sort of process. Now, when air does reach the dew point, and it's in the atmosphere as opposed to close to the ground, clouds are formed. Clouds are nothing more or nothing less than particles of water or ice that are suspended in the atmosphere. Though it is a little bit more complicated than that, because air that's suspended, or moisture that's suspended in the air in the atmosphere, has to form onto something. And that saturation takes place on tiny little, what are called condensation nuclei, tiny little particles of dirt and ash and all sorts of salt, all sorts of material that's suspended in the atmosphere already. When that moisture attaches and affixes onto one of these precipitation nuclei, it can exist as water or as ice in the atmosphere. So some clouds are composed of ice crystals. When the particles are quite small, they can actually exist in the atmosphere as what are called supercooled particles of water, which means that their temperature is well below freezing, but they are still suspended in the atmosphere as particles. Now, as clouds form, they come in all sorts of different shapes and sizes. And I'm not going to spend a lot of time talking about this right now, but I recommend that you look up these clouds in the text and then maybe Google some interesting pictures of clouds to learn more about clouds. The really important thing to know about clouds is that they come in families, and the biggest sort of family differentiation are the puffy clouds, which are called cumulus clouds, that are shown up here, and the flat gray clouds that are called stratus clouds. And those two different cloud families are related directly to the stability of the air, something that we're going to talk about later. Clouds are named and put into families in a bunch of different ways. Not only do we have a differentiation between cumulus and stratus, but we also have nimbostratus or cumulonimbus clouds. These are stratus or cumulus clouds that have precipitation associated with them. There's also a kind of cloud called stratocumulus, which we're actually seeing a little bit of right here, which are layers of cumulus clouds that often occur in fair weather. Clouds can also be differentiated in terms of their elevation in the atmosphere as well. Very high clouds are called cirro clouds. Middle ones are called alto clouds. This is a picture from the text that shows a whole bunch of different types of clouds, but there are many other types of clouds besides the ones that we're seeing right here, and they're often associated with different types of weather patterns, and there's a lot of interesting things that are related to clouds that I encourage you to explore a little bit more. Clouds that form on or near the surface of the Earth are fog. Fogs usually take place because the air that is in the atmosphere close to the ground is cooled for some reason because of its proximity to the ground. Oftentimes this takes place because the ground is losing so much energy so quickly in the middle of the night that it cools down much faster than the atmosphere, and then the air reaches the dew point. This is called radiation fog, and it's related to the loss of radiation that we talked about before when we talked about temperature patterns. Advection fog takes place when a body of moist air, oftentimes from the ocean, is pushed over the land, which is relatively cool, and it begins to condense. It goes through the transformation from water vapor to liquid water, and it forms fog around the ground. Evaporation fog will often take place when we have a liquid body, a lake, and cold air moves over the top of it. And as particles of moisture evaporate from the surface of the lake, they condense into cloud fog, into little ice particles or into water particles. This often happens in very cold conditions in places like Alaska, but in other situations as well. Precipitation is formed when the amount of moisture that is collecting on precipitation nuclei grows so large that whatever is keeping that moisture suspended in the atmosphere, which we'll talk about in a later lecture, can no longer suspend that moisture in the atmosphere, and it starts to fall out. This usually takes place because cloud particles are very tiny, but if there are lots and lots of these very tiny cloud particles colliding with one another, they'll start to coalesce into a much larger raindrop that's much more difficult to suspend. Or, of course, it could be a frozen piece of moisture. It could be snow or sleet. It could be hail or something that's pretty cool called graupel that I'm going to show you a picture of in a little bit. All of these forms of precipitation, rain, liquid rain, which of course takes place in different sizes as well, great big raindrops versus tiny ones that represent an important difference in the type of rain that falls, or the frozen types of precipitation, all come about for the same reason. The air mass that they're in is reaching that dew point, and it starts to form first clouds, and then it starts to ultimately form the precipitation that comes out. Sometimes precipitation is deposited directly onto the ground from a mass of air, surface precipitation, the most common of which is frost or dew, but it can also involve a type of precipitation called rime or hoarfrost. So here are some pictures of all these things. Some frost right here, hoarfrost, or rime rather, that is caused as a result of air blowing over a surface and beginning to collect on it in using the process of deposition, going directly from vapor to a solid form. This is the hoarfrost over here. These are pieces of hail that have fallen, which are frozen pieces of water that collect more and more layers over time, often associated with either thunderstorms or a lot of very unstable air. Sleet is another frozen form of precipitation that, again, is very similar to what we see with hail, just at a smaller scale, and usually a lot more of it. Over here, this is graupel. Graupel falls when you have a tiny little piece of frozen precipitation that becomes rimed, so it gets its own surface layer on it through that process of deposition that I mentioned before, and it forms these soft little particles of frozen precipitation. Pretty cool stuff. Snow, of course, is a major form of precipitation. I'm not going to spend a lot of time talking about snow, but snow actually comes in lots and lots of different forms. Most of us are familiar with the idea of a six-sided dendritic piece of snow, sort of the classic kind of snowflake. But snow actually comes in many other forms that we may not recognize and we may not see when it falls because they're much harder to identify than the beautiful flowers of snow that are often associated with snowfall. And these different types of frozen precipitation are all related to the temperature at which they're formed in the atmosphere, as well as how much humidity, or what's called vapor pressure, there is in the atmosphere. These are just some examples, and these are some pictures showing these beautiful forms of frozen ice. One last thing I want to say about snow is that when snow does fall onto the ground, it actually starts to go through a metamorphosis process as well, which is shown in this diagram right here. We start with a dendritic form of snow, and over time it starts to collapse until it becomes a small rounded crystal of snow. And that's really important, especially to people who are thinking about the formation of the snowpack and its relationship to avalanche risk. So that's all right now. The next thing that we will be exploring will be how we get the air to cool off so that all this first condensation and then precipitation can actually take place.